All right, welcome to lesson 11 of Unit 5. We are, I think, exactly halfway through Unit 5. I think there's like 22 lessons or something like that. Okay, so we're moving away for a little bit from functions to volume. So for activity 1, it shows all these different shapes. It says these are drawings of three-dimensional objects, which one doesn't belong. So you can really pick any one of these and just give your reasoning. So pick one, and then like why is it different? Like how and why. So you could say like B because it has no base. It's a spherical, something like that. Or you could pick any of the other ones and explain why. You could say A because it only has one base. You know, the others either have multiple or none, something like that. Okay. Activity 2 says that I'm going to give you a graduated cylinder with water and all this stuff. We're not going to be able to do that, unfortunately, since we're not in class. So I'm going to use a virtual one. So you're essentially going to have imagine having like this cylinder and you're filling it with water, or it's filled with water, and then you have like some sort of objects in it. What's going to happen to the water? Is it going to go up or is it going to go down? So think about that, and then how would that make your graph look? So we're going to have to go back and forth. So let's see if this works. Okay, that's interesting. Is it not going to work? Okay, there it goes. Cool. So your volume is at 0, your height's at 0, the diameter is 5 centimeters. So let's fill it and stop. Oh, wow. Okay, let's reset it. Just ignore that. Okay, let's try to fill it to like, if I can get it to fill to 10. Okay, 10.2, close enough. So we can like just call it 10. So when the volume is 10, the height is 0.5 centimeters. Okay, so when the volume is 10, the height is 0.5. So we can fill this out. Volume is 10, height is 0.5. Okay, so then we go back to the thing, which hopefully, okay, so let's fill it to maybe 20. Oops. Let's try to fill it just to 20. Darn it. Oh my goodness. You guys would probably have done better off doing this on your own. You can feel free to follow the link and try it on your own, because I don't know how accurate it's going to be. Oh my goodness. This is really frustrating. Okay, perfect. Okay, so at 20 it's 1, and looks like it's going to be pretty linear. So 20 is 1. So I mean, we could say if we do 30, 40, 50, 60, if it's going to go up by half, so we'll do one more just to make sure, but I have a feeling, 30 is going to be 1.5, and then 40 would be 2, and then 50 would be 2.5, and then 60 would be 3. But I mean, we'll check just to make sure that is the case. Where is Safari? There it is. Okay, so we'll go to 30. Close enough. So yeah, 1.5 is at 30, and then if we go to 40 is about 2, and then if we were to go to 50, it'd be about 2.5. So my guess was right. So it's going up by half. Okay, so it wants you to create a graph that shows the height of the water in the cylinder as a function of the water volume. So remember, whenever you're doing these function problems, the one that is listed first, so where is it saying this again? Okay, let me highlight it so everyone's on the same page. So height of water in cylinder as a function of the water volume. So the first thing, they just can't work this iPad. Okay, so height of the water in the cylinder is the first thing listed. So that is going to go on the Y. So this is height of water. And then the other one is volume, and that's going to go on X. So it's always, that's the Y and that's the X, in case you're curious. Okay. So what do they want you to do? Create a graph that shows the height of the water. So we could start it at, like, if this is going in increments of half, I could say, like, that's 1, you know, that's 2, 3, 4, 5, like that. And then we could say over here, we could go by 10. So like 10, 20, 30, 40, 50. Okay, so then if I'm graphing it, my first one is 10 and 0.5. So 0.5 is right about there, 10 is there. And then for 20, I'm at 1. So then I'm like here. And then for 2, I'm sorry, for 30, I'm at 1.5, so 1.5 30 is right here. And then 40, I'm at 2, so then 2, and then 40. And then 50 is 2.5, 2.5 is right about here, 50 is here. So you guys get the idea, and then you can draw your line, which technically would have gone through the origin, but because I mean you started with nothing, so like technically this was 0 0 to begin with, right? Anyways, you can draw better. We created a graph that shows the height of the water as a function of the water volume. Choose a point on the graph and explain its meaning in the context. So number 4 is just like it's kind of silly. We already talked about this. But like if I picked, I don't know, this point, right? That point is 2, 40. You would just be like, oh, at, you know, whatever 40 is, at 40 centimeters of water, volume is 2.5, or sorry, 2. Okay, here's a little graph showing 3 different ones. I'm not entirely sure. Oh, this is just a hypothetical graph. I see. So it's just saying like if, you know, if what we graphed changed, like, you know, you doubled something or whatever, like how that would look a little bit different. Don't worry about that. Okay, activity 3. So this is kind of hard to see. Hopefully you can read it better in your book. But the first problem says the graph shows the height versus volume function of an unknown container. What shape would this container have? Explain how you know and draw a possible container. I'm just going to tell you right off the bat, they're still talking about cylinders. I don't really know how they could expect you to know that without telling you. So we're talking about cylinders. Cylinders are like this, right? That's terrible drawing, but you get the idea. Like a graduated cylinder, like it's a cup, pretty much, like a glass, but not, the sides are like straight up and down, make 90-degree angle with the bottom of the cup. So if you look at this first part and then you look at the second part, they're two things are happening. So as you fill this container, the height of the water changes. So it's like, the volume is 10, 20, 30, 40, whatever. And then, as the volume increases, the height of the water obviously increases because they're directly proportional to each other. So they want you to draw what it would look like. So the fact that it has two distinct parts means that it's two different containers, right? Because how could you all of a sudden now have a different relationship between volume and height if it wasn't a different container, if that makes sense. So the steeper the slope, the narrower the container, and then the shallower the slope, the wider the container, is a general rule. So for the first one, the bottom cylinder is kind of going to look like something like that, right? And then the top cylinder is going to just be like the same, except the difference is that it's going to be wider because the slope is like this slope would be what? Like if we made this, it would be 2. But this one, if we were to get its slope, oops, it would be, I don't even know if there's a friendly way to do this one. Let's see, it starts at 40 and then it goes to 50, only goes up 1/2, but if we were to do it from, let's say from here to here, oops, what does that, rise 1, run 1, 2, 3. Okay, so your slope for that one is 1/3, so it's way shallower. So then you're gonna have this like terribly, this is a terrible drawing. Please do not draw as badly as I am drawing. But your other container is way wider because the slope is shallower. So it just means like that the radius is bigger. I hope that kind of makes sense. So the same thing you're going to do for this one. This is showing, and I'll start it out. So it's 3 different parts. So there's this one, here's one container. What would that container look like, do you think? Here's this container, and then in between, I did it that way on purpose because I feel like it makes more sense to see the middle one after the fact. And then here's this container. So remember, the shallower the slope, the wider the container. You draw the bottom line first. So the orange line is going to be pretty similar to the first container we drew here. Then the middle one is going to be, if you can hear my dog growling, I'm really sorry, that's distracting. And then the middle one is going to be a little short container because it's a short line and it's really steep, so it's going to be like tall, well, it's going to be narrow but like short in height. And then your last one, the red line, you would draw something really wide, right? Because it's got a similar slope. And if you need to, you can, count the slopes, calculate the slopes. Are we done? Yeah, I guess so. What do they want us to learn in this lesson? They want us to collect data about a function. So this part, collecting data about a function, that was the cylinder app that we went to. We graphed it. And then describe the graph of a function in words. That would be, I guess that's what we did in this activity, except we described the graph of a function in pictures. If you want to describe it in words how I did for the second one and not draw the picture and just write out what I said, that's totally fine, if that makes more sense to you. All right, this is a little tricky, especially for people that, maybe doing things with shapes isn't the friendliest. It's more geometry than algebra, right? But still important. Okay. Remember, help session is at 11:35 to 12:05, and you need to do practice problems.